Hey guys, welcome back. So today I will be solving another problem from October LeetCode challenge. So let's go into it and check what today's problem is. Okay. So today's problem is called bag of tokens. Okay. Actually, you know what? I actually know this problem. I mean, I have seen this problem before, but never actually solved it. Let's see what it says. Okay, it says you have initial power of p and initial score of 0 and a bag of tokens where tokens of I is valid for the value of ith token, 0th index. Okay, so your goal is to maximize the total score by potentially playing each token in one of either these two ways. So what are the two ways? One is the current power, which is which will be given to us. Okay, the current power is at least token of I, so at least means like it has to be greater than or equals to the power. Then that ith token is played face up. Okay, so that means you will be losing that token. Okay, and we will be gaining 1 point. Okay, and the other way is you can trade in your one token to get ith token face down. Okay, so that means basically there are two ways. One is either you have power which is either equal or more than the current token I, and we will be getting a point for that by trading in that much token. So your power will be reduced by that much. And another way is you will be deducting one score from your side, and you will be getting the current index or token of ith power by losing one score. So this problem statement is bit confusing. So once you look into some examples, you will understand. So let me just explain this example itself because it's pretty standard size, and it is also explained over here. Like, so here we will be given with this many tokens and a power of 200, and the output is coming out to be 2. And let's see how it's coming out to be 2. So play the tokens in the order to get the score of 2. So what is the order? First of all, the 0th token, which is 100, which is same as or rather than this 100 is less than or equal to this 200. So that means that we can trade in this much amount of token to get 1 point. So first transaction is like that only. So after that, our power left will be 100, and then which is the immediate next token? 200. So our power left is 100 and the immediate next token is 200, so we cannot get another point. But what we can do is whatever the token we already had in the previous transaction, we can trade in that token. In return we will get any of this tokens amount of power. So we can choose either 200, 300, or 400. But what will be the most beneficial for us? If we get the most amount of power by giving the minimum amount of token, which is in this case 1. So we can get the 400 power by giving the 1 token. So we will be having now 500 power. So after having 500 power, we can get 2 tokens, both this 200 and 300, because the power is 500. So you are getting right. So the two things which we observed is whenever we are gaining a point, we have to choose a token which is having minimum value. So minimum value will be deducted from our power and we will be getting a token. And when we are getting more powers added to our existing power, we have to choose the power which is the greatest, because we are trading in our 1 point, so that we get the most amount of power. So this will be the main crux of the problem. So first of all, for getting like order of one operations of maximum and minimum, what we can do is we can sort the array first of all. So that is the thing we have to notice over here in this problem. So the value will be like 10 to the power 4. That is not that much also. Okay, and the length is only 1000. So sorting will work. So first of all, whatever the list of tokens we are getting, we have to sort that. So okay, no issues. Tokens dot sort. So first of all, it will be sorted. Then it will have a variable, let's say score. So we have to calculate the maximum score. So let me just take two variables which will be tracking the current score, and another will be tracking the maximum score. So one is core, another is, let's say, max score. So both of them will be zero initially because we don't have anything right now as of now. So we will be taking two variables to iterate over this tokens array which we have sorted in the line 3. So first variable, let's say it will be obviously I, and another will be j. So first one will be starting from the initial point or starting point 0, another will be starting from the last end, because we want the least value also, and we also can like access the greatest value which will be at the end of the array. So length of tokens minus 1. So this is the initial setup for our code, and now we have to write the main logic of this problem. So we will be having a while loop. So we will be checking unless and until they are overlapping or crossing each other, we will be continuing this loop. So the first statement or first condition which we need to check is if uh, if the power which we have already is greater than or equal to whatever the token is at ith index, then this means what? We can have a score. We can have a score. Okay. So we can have a score. So by having this score, what will happen is now our power will be deducted by that much amount, which is the tokens of I. Yeah. So these two steps will be done. So after that, what will happen is um, we have to increment the ith pointer, because that token is already used, so we cannot use that anymore. So ith pointer will be increased by 1 from the left side. And also in this step, we have to keep track of whatever is the maximum score we got until now, because this is the only place where the score is getting incremented. So we have to also keep track of maximum score over here. So max score will be whatever the max score there was before and whatever the score we got right now. So max of these two. So this is one condition. Now elif, what other condition can it be where my score is greater than 0? That means I have at least 1 point to, or at least one score to trade in for more power. So if this is the case, logically which power I want, because I am giving away one score, so I will be obviously wanting the most amount of power I can get for one score. So what is the most amount of power? That is the last index or the j. So that means what? Now I will be adding uh, tokens of j, and as it is used, that means also j minus equals to 1. And before that also, what we need to do was, what we need to do is like the power is now getting increased and our score is also getting decremented, because we are trading in our score, right? So after that, this much. So power is getting incremented, score is getting decremented, and j is getting decremented because that token is already used. Okay. So that was the third condition. And what if there can be a condition where none of this is like satisfying? Because there can be one condition while traversing through the array that we see that p is not more than or equals to any of the tokens, and also we don't have any score to trade in for more power. So that means what? Basically our game is finished. So we have to return whatever the maximum score we have obtained so far. So return max score. But here the program doesn't terminate, because there can be another possibilities where it will happen in some cases also that we are keep on trading and trading, like getting more power, getting more scores, and so on and so forth. And after that, at some point, this termination condition of while is getting kicked in. So that time this while loop will be finished. So after that also we have to return this max score if there is some max score. So that's why we have to also write this at the last line outside the while loop, like this. So now our code is complete. So this is the code. So now let's run it and check if it's working or not. Okay. So yeah, this is working. So let me submit it and let's see if it gets accepted or not. So here we can see it gets accepted. So this is basically a kind of greedy approach, because we are greedily picking whichever like token or whichever point or whichever power. This problem has so many terms, so you can understand like what I'm saying, why this is greedy. So the time and space complexity is pretty easy to calculate, because for this line itself, it is like big of n log n, and except that for this is a linear loop, so big of n. So ultimately the time complexity is big of n log n, and the space complexity is big of 1, because it's constant, because we are just using some variables over here. So that is how we have to solve this problem called bag of tokens. So I hope you like this video, and if you did, please make sure to subscribe and also like this video. Thank you.